Hey, what's up guys? In this video, we're going to solve a coding interview problem, valid anagram. Given two strings s and t, write a function to determine if t is an anagram of s. This is the problem statement. Now let's see what is an anagram. I got this definition from Wikipedia. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. This is the formal definition of an anagrams. In my definition, or in my thoughts, two strings are anagram of each other if they contain same character in same quantity. If we have two string S1 and S2, this two string is an anagram of each other if they contains same character in same quantity. Hope you have understood what is an anagram. Now let's see some examples. If you're given s equals to this string and t equals to these strings, we have to determine whether these two strings are anagrams of each other or not. If they're anagram, we have to return true. If they are not anagram, we have to return false. These two strings contains same character in same quantity. In these strings, we have 3a, a. And in this string, we have 3a as well. In this string, we have n. N appears in these strings only once, and in these strings n appears only once. Then we have z. Z appears in these strings once, and z appears in these strings once as well. Then we have r. R appears once. Here r appears once. Then m appears once, and here also m appears once, and a appears 3 times. So we see that the two strings contains same character in same quantity but in different order. So s and t is an anagrams of each other. So for this input we have to return true. If you're given s equals to rat and t equals to car, now we have to determine if they are anagrams of each other or not. In these strings we see r appears once. In these strings r appears once. That's okay. Then we have this character a. This character a appears once, and here we see a appears once. Then we have t, and we see that t do not appears in these strings t. So these two strings are not anagrams of each other because they are not contains the same character in same quantity. So for this input we have to return false. Now how we can solve this problem? Let's see how we can solve this problem. For sake of understanding, let's assume we're given s equals to anagrams and t equals to these strings. In this video, we're going to solve this problem in 2 different ways. First, we will solve this problem in big of n space complexity and big of n time complexity. Then we will solve this problem in bigger of 1 space complexity and bigger of n time complexity. First, let's see the bigger of n time complexity and space complexity solution. For that, we're going to use a hash map. Let's see how we can solve this problem using a hash map. Alright, let's suppose that we're given these two strings, s equals to these strings and t equals to these strings. And we have 2 hash map. Hash map is for this string s, hash map t for this string tree. Now we're going to traverse this string from left to right, and we're going to construct this hash map. Let's see how we can construct this hash map from these strings. As key we will store the character, and as value we will store the appearance of a specific characters in a given string. Okay, so first we have this character a. We see a do not exist in this hash map, so let's add a as key and as value by default 1. Then the next character is n. N do not exist in this hash map, so let's add n as key, and as value let's insert here 1. Then the next character a. We see that a already exists in this hash map, so let's increase the value of a. The value is now 2. Then the next character z. Z do not exist in this hash map, so let's add it as key and as value 1. Then we have r. R do not exist in this hash map, so let's add r and as value 1. Then we have a. A already exists, so let's increase the value of a. So 2 is now 3. Then the next character we have m. M do not exist in this hash map, so let's add it. M and as value 1. So we have constructed the hash map for this string s. Now let's construct this hash map for string t. First we have the character n, so let's add here n as key and as value 1 by default. Then the character we have a. A do not exist, so let's add as key and as value 1. Then the next character z. Z do not exist, so let's add here z and as value 1. Then a. We see a already exists, so let's increase the value of a. Then r. R do not exist, so let's add r and as value 1. Then we have a, so let's increase the value of a since a already exists. Now the value of a is 3. Then we have the character m, and m do not exist in this hash map, so let's add it and value 1. Now we have constructed this two hash map. Hash map s for string s, hash map t for the string tree. Now what I'm going to do, I'm going to traverse the first hash map, and we're going to compare every single key value. First we have a, right? Key is a. So let's see the key in this hash map, and that is a. Here we found, and the value we see is 3, and they are match. Since they are match, we'll move to the next character. We have the next element n, right? So against n, what do we have in this hash map? Against n we have 1, and here we have 1 as well. So this is a match. So let's go to the next one. Next one g, and against z we have 1, and in here we see against g we have 1. They are match. So let's go to the next one, that is r, and against r we have 1, and here as well against r we have 1. Then next one is this one. Here we have m, against m we have 1, and against m in this hash map we have 1 as well, so they are match. And we're done. We see that all the key value pairs in two hash map are matched. So the given two strings are anagrams of each other because they contain same character in same quantity. And this is hash map solution for this problem. This solution will take big O of 3n time complexity for the worst case scenario, and this is equivalent to big O of n. And this solution also takes big O of 2n time complexity to construct this two hash map, and this is equivalent to big O of n. So the time complexity for this solution is big O of n, and space complexity is big O of n as well, where n is the length of the given strings. The first thing that we have to check, first we have to check the length of those two strings. If we found the length of those two strings are not same, we will return false, because two string is not anagrams of each other if the length are not the same. So this is my solution, and this solution takes big O of n space complexity. Can you optimize this solution? Can you solve this problem in constant space complexity? Now let's see how we can solve this problem in constant space complexity. To solve this problem in constant space complexity, we'll use an array. In English alphabet, we have 26 characters. For these problems, we're given only the lowercase English alphabet. We can create an array of length 26 and we'll map A to index 0, B to index 1, C to index 2, D to index 3, and so on and so forth. Now let's see how we can solve this problem. To solve this problem, we're going to use these 3 examples. Now let's see how we can solve these problems in constant space complexity. Then we will optimize our algorithm even further. For now, let's assume we're given s equals to these strings and t equals to these strings. Alright, this is our array of length 26, where A maps to 0, B maps to 1, C maps to 2, and so on and so forth. This is your algorithm to solve this problem. First, we check if the length of the two strings are not the same, we'll return false. Then we are declaring this array of length 26. Initially, we have the value is 0. Then we have this loop. Now, let me show you how it actually works. For every single character in this string h, we'll increment the value at a corresponding index that the character maps to. For these strings, we will decrement. After doing that, if we found all the array elements are 0, then we will return true. If any of the array elements are not 0, after doing this for loop, then we will return false. Now let's see how it actually works. The first character we have here A, and the first character we have here N. For this character, we will increment the value at the index of this corresponding character. This is the index of this corresponding character, so we'll increase the value. So in this case, 0 will be changed to 1. So now the value of this element is 1. And for N, this is the index of N, and we can get the index by subtracting the ASCII value. If we subtract ASCII value A from N, then we'll get this index number. Okay, and here what we did, at this index we're going to decrement. If we decrement, this value will be changed to -1. So now the value at this index is -1. Okay, then for next iteration, this is the character for these strings and this is the character for this string. Here we have N, right? So we'll increment for this character. If we increment, then this value will be changed to 0, and we'll decrement for this character, so this value will be changed to 0 as well. For next iteration, we have A and Z. For A, we will increment. If we increment this value, we get 1. For A, then we have the value at this index is 1, and we have to decrement at this index Z. So if we decrement right over here, the value is -1. Then for next iteration, we have Z and we have A. For next iteration, we have the character Z and A. So for first thing, we have Z. So for the character Z, we'll increment. If we increment here, this value will be changed to 0. For this character A, we will decrement. If we decrement, this value will be changed to 0. Then the next character is R, and here R as well. So we will increment at R. If we increment, this value change to 1, and if we decrement, this value change to 0. Now the next character is A, and here A as well. First we'll increment for this string, then this value will be changed to 1, and we'll decrement for this string, so this value will be changed to 0. Then the next character is M. We'll increment at M, so here if we increment, the value changes to 1. If we decrement, this value changes to 0. So we're done with this for loop. Now we're at this for loop, we're checking the value of this array. If we found any of the value is not 0, then we'll return false. Since we see the value for this array is 0, that means all the element of this array are 0, so that's two strings is an anagrams of each other. We're returning true for the given string, right? So the answer is true for the given string. This is how we can solve this problem in constant space complexity. For better understanding, I will highly encourage you to go through with your own examples. Then it will make sense. This is not a hard problems. I think this is a easy problem if you try with your own examples. The time complexity for this problem is bigger of n plus 26. The time complexity for this problem is bigger of n plus 26. Since 26 is a constant, so the overall time complexity is bigger of n. The space complexity for this problem is bigger of 26. Since 26 is a constant, so the space complexity is bigger of 1 or order of n, or you could say constant space complexity. So the solution will take bigger of 1 or constant space complexity. This is how we can solve this problem. We can optimize this algorithm even further. Let's see how we can optimize it. For that, let's take this is an example, and this is our optimized algorithm. Instead of doing increment and decrement together, we can first do increment, then we can do decrement, and we can check if we found any negative value, then we will return -1. So for this string s, we will increment. At this position we will have 3, and at the position c right over here we have 1. So we have 3 and 1 after doing this for loop. Then we have this for loop, right? And here we're going to decrement and we're going to check. First we have a, so this value will be changed 3 to 2. Then the next character is c, and we see that at this position we have the value 2 is not less than 0. So let's go to the next iteration. We have the character c, so let's decrement here 1 change to 0, and we see this value is 0, not less than 0. So let's go to the next iteration. For the next iteration we have the character c, so let's decrement again. If we decrement this, then this value changes to -1, and since we see the value is less than 0, we will return false. So for this given input we will return false, and you see that we made here just 3 operations for these strings, and we don't have to go through all element of this array. Now you might ask, if we have input that never changed the value of this array to negative, then what's going to happen? And the answer to this question is that, and there is no chance. First we have checked the length of the two given string. If the length are the same, during the iterations it will change any of the element to negative. Okay, you can take some examples to understand it. And this solution will take bigger of 2n time complexity, since we're traversing this two string. So the overall time complexity is bigger of n, and the space complexity is bigger of 26, and that's equivalent to bigger of 1. So this solution will take linear time complexity and constant space complexity, and this is how we can optimize this solution. Now let's take another example to understand it clearly. So we're given this to a string, and this is your algorithm and this is your array. So first we have this string a. At a we will have 1, and at c here we will have 3, and we see that here we have a, so it will change to 0, it will decrement, then again we have a, and it will change this to -1. So if this element gets changed to -1, it will return false, and we don't have to check any more element or any more character in these strings. So we get false for this input, and the output for this input is false. And this is how we can solve this problem. For better understanding, I will highly recommend you to go through with your own examples. Hope you have understood this solution. and I will attach the source code to this video. You can check it out. We have solved this problem in two different ways. First, we solve this problem using a hash map that takes linear space complexity. Then we have solved these problems using an array that takes constant space complexity. Hope you have understood this concept. If you have any question or if you have any suggestion, let us know. Thanks for watching this video. I will see you in the next video.